Alright guys, today we're going to learn about solving one and multi-step equations. Okay, we have two goals that we're looking at today. Solve one-step linear equations and solve multi-step linear equations. Alright, so let's take a look at our first couple of sentences here. Inverse operations are used to solve equations. Inverse operations are kind of like opposite operations. For example, the opposite of adding is subtraction. The opposite of dividing is, I'm sure you can guess it, multiplication. All right, we use inverse operations to solve a problem and get the variable by itself. Okay, so that is our main goal here, is to get the variable by itself. You're going to do that by doing a bunch of opposite operations everywhere. So let's take a look at a couple examples. R minus 3 equals 16. Our goal is to get R by itself. So how are we going to do that? We have to get rid of our negative 3 here. What's the opposite of negative 3? Adding 3. So you get R equals, because these cancel out, you get R equals 16 plus 3, R equals 19. Okay, you're always looking to do the opposite. Number 2, G minus negative 7 equals 23. Okay, this one's a little tricky, but if you use our rule, when you have two minus signs in a row, it turns into an addition. Really, it's G plus 7 equals 23. So now we have to get G by itself. What number is on the side of G? Plus 7, so we have to do the opposite. These cancel, you're left with G equals 16. All right, the most important step here is that you're doing, it's kind of like a mirror. You have to, what you do to one side, you have to do to the other side. Okay, so you can't just subtract 7 on one side and call it done. You have to do the same on both sides of the equation. If you think of it, there's like a line down the middle for these equations. Okay, so 6 plus d equals negative 4. What's the opposite of 6? Okay, we're not going to move our negative 4. We're trying to get d by itself. So here, what's the opposite of 6? Minus 6. Notice how I'm going to do it on both sides. These cancel. You're left with d equals negative 10. There's your answer. Okay, let's try one more, and then I'm going to give you a chance. X minus 8 over 3 equals 1 over 3. Same kind of deal here. It doesn't matter if there's fractions or not. You're still doing the opposite to get the variable by itself. What number's on the side with the variable? Negative 8 over 3. So you're going to do the opposite. These cancel. You're left with x equals 1/3 plus 8/3. You get 9 over 3, which simplifies to 3. Always simplify your answer if you can. All right, I want you to go ahead and try 5 and 6 on your own. All right, so how'd you do? We have x equals negative 60 and b equals 22. Hope you did all right here. This number 6 was a little tricky. Negative 8, what's the opposite? Positive 8. So you're adding 8 on both sides. Now let's look at solving one-step equations using multiplication and division. Okay. So here, negative 3x equals 12. Now, negative 3x, we know that this is a multiplication. So we can go ahead and divide to get rid of our negative 3's. Why? Because negative 3 divided by negative 3 is 1, and you're left with 1x. Now, technically, we know that 1 does not need to be there for x to be by itself. Okay, so now it's 12 divided by negative 3, you get negative 4. Number 8, x divided by 4. You just said it, divided by 4. What's the opposite? Multiplication. So you're going to multiply by 4 on both sides. So you're going to get x equals 400. All right, number 9. Negative 15x. We know negative 15 attached to the variable means multiplication, so we're going to go ahead and divide by negative 15. You get x equals 6. All right, why don't you go ahead and try 10, 11, 12 on your own. All right, go ahead and check your answers. I hope you did all right here. All right, keep in mind with number 11, this negative can technically be attached at either the top or the bottom. So I just go ahead and multiply it by negative 9, which gets our x by itself there. All right, hope Hope you did all right. Remember that dividing by a fraction is the same as multiplying by the reciprocal. Now, the reciprocal, remember, is just a fraction flipped. So 5 over 6, the reciprocal would equal 6 over 5. So let's go ahead and take a look at a couple of these. As you can see up top here at number 10, x divided by 10 is a little different here than 13, which is 5 over 6 times x. Okay, so in order to get rid of both the 5 and the 6 this time, we are going to multiply by its reciprocal. Why? 6 divided by 6 is 1, 5 divided by 5 is 1, and you're left with just x. So in this case, 30 times 6 divided by 5 is 36. Let's see how that's a little bit different. We're not multiplying by any whole number, we're actually multiplying by the reciprocal fraction. So 3 over 4x, how are we going to get rid of the 3 over 4? We are going to multiply by 4 over 3. 4's cancel, 3's cancel, you're left with x equals negative 32. Alright, and number 15. In number 15, it's negative 1 over 4. Now it doesn't matter where you attach it to, just make sure you're flipping the fraction and keeping one of the negatives in there. So negative 4 cancel, 1 cancel, you get x equals 52. Okay, so the reciprocal is just the fraction flipped. Alright, let's take a look at solving multi-step equations now. Alright, when solving multi-step equations, it helps to think of addition and subtraction as opposite operations than multiplication and division. They are physically separated from the variable, and they also do not change our number quite as rapidly as multiplication or division. Why does it help to look at addition and subtraction as the opposite operation? This helps us to act as math cheetahs and attack the weaker operations first. Let me show you what I mean. So in this equation here, 3x plus 10, what numbers are on the same side as x? So if you're splitting the equation down, you have this side here is x, so you have 3 and 10. What operations are being performed? So our operations are where? You have multiplication and addition. Now remember, you are not using x anymore for multiplication, so a dot, parentheses, anything works. So in this equation, what number are you going to undo first? You always want to undo addition or subtraction first. So in this case, you're going to undo the 10 by the opposite of addition, subtraction. So you're going to subtract 10 on both sides. Okay, why? Because those cancel. You're left with 3x equals 27. What number will you undo second? So again, you're taking a look at the side of the x, and this is right back to our one-step equations here. You're going to divide by 3. So you're going to get rid of the 3 by division. Okay, so you always want to, when you have multi-step equations, you always want to add or subtract first before you multiply or divide. Multiply or divide should be your last possible step. So let's take a look at a couple examples here. So we want to solve for x. Okay, we have two sides of the equation here. So what numbers are on the side of x right now? You have 2x and you have negative 5. Okay, let's take care of our subtraction first. Minus 5, we're going to add 5 on both sides. Okay, those cancel, so you're left with 2x on this side over 20. Notice I'm just writing my equal signs right underneath every single time. I'm keeping everything lined up on its own separate sides. Okay, so how are we getting x by itself now? You're multiplying, so the opposite would be division. So x equals 10. Notice I did the same thing on both sides. I added 5 on both sides, and I divided by 2 on both sides. Okay, let's take a look at 17. 4x plus 3 equals 11. Okay, take care of the addition first. So plus 3, so you would have to subtract 3 on both sides. You're left with 4x equals 8. 4 times x, the opposite would be division. So you're left with x equals 2. Okay, number 18. The x is on the left side, so we got to move every number to the right. Start with minus 9 by adding 9 on both sides. Therefore, 1/2 x equals negative 12. All right, now, oh, I'm sorry, that's not negative 12, negative 6. Now remember, 1/2. You can multiply by the reciprocal to get it by itself. These cancel, cancel, cancel. So you're left with x equals negative 6 times 2 divided by 1. The answer is negative 12. Why don't you go ahead and try 19, 20, and 20. All right, why don't you go ahead and check your answers. All right, so everything here is multi-steps, but all we've done is 2 steps at a time here. Okay, so hopefully you guys are picking this up a little bit quicker here. Okay, so you're always looking to get the variable by itself by doing the opposite operation. All right, let's take a look at multi-step. Okay, nothing that we haven't done in the past. We're just going to start with combining some like terms. Okay, so let's take a look at 22. When you combine like terms in equations, you always want to make sure you're only combining the like terms on each side of the equation. Okay, so if you take a look at number 22, 3x and negative x are like terms and they make 2x. How about 15 and 41? No, they can't be like terms because they are on different sides of the equation. So you're going to go ahead and just write out the equation. Now we're right back to where we started, okay, solving equations. So you want to get rid of 15 by subtracting. If a 2x equals 26. And then you're going to go ahead and divide, and you're left with x equals 13. Okay, again, 2 separate sides of the equation. So we have 2 5ths y and negative 1/5 y, which makes 1/5 y. 9 and negative 1 cannot be like terms because they're on opposite sides of the equation. So you're going to go ahead and write that down. Okay, go ahead and do the next one. So you have minus 9 on both sides now. So you're left with 1/5 y equals negative 10. So then you're going to go ahead and multiply by the reciprocal. So you get y equals negative 50. Let's try one more before you try a couple on your own. Here you got 2x and negative 9x. As like terms, 2x minus 9x, negative 7x, okay, plus 17 equals negative 4. We know they're on different sides of the equation, so they can't be like terms. So let's start off here by subtracting 17 on both sides. You get negative 7x equals negative 21. You're going to go ahead and divide, and you get x equals 3. So why don't you go ahead and give the next 3 a try on your own. All right, now let's take a look here. 25x equals 2, 26x equals 3, 27x equals negative 15 over 2. So 27, we saw something different here. On both sides of the equation, you had some like terms, something we hadn't had in the past. 20 and 12 are like terms over here. So you got to combine those. You're not combining the two because it is on the opposite side of the equal sign. Okay, so that gets carried down, but the 20 plus 12 needs to be combined. All right, let's go ahead and try some with the distributive property. Anytime a number is attached to the parentheses, remember we are distributing. So, got to start here. 5 times x and 5 times negative 7. Okay, so you get 5x minus 35 equals 90. So go ahead and start solving then. Add 35 on both sides. 5x equals 125. divide, and you get x equals 25. All right, 3/4 times x and 3/4 times 8. So 3/4 times x is just 3/4 x. And you get 3/4 times 8, which comes out to be plus 6, equals 12. Subtract 6 on both sides. 3/4x equals 6. Okay, we can multiply by the reciprocal here. All cancels. You're left with x equals 6 times 4/3, and you get x equals 8. Okay, number 30, we're going to go ahead and combine everything here together. So you got to distribute first before you combine your like terms. So carry your 5x down. You have 3 times x, so plus 3x. 3 times 4 plus 12 equals 28. Go ahead now, combine your like terms. 5x and positive 3x make 8x. Plus 12 equals 28. Now you can go ahead and start solving on your own. 8x equals 16. Divide, and x equals 2. Let's try one more before I let you venture out on your own here. 4x comes down because we have to distribute -3 times x and -3 times -2. So -3 times x is minus 3x. -3 times -2 is plus 6 equals 21. Go ahead and combine your like terms. 4x minus 3x just makes 1x. So this one actually comes out to be a little easier because now we're subtracting by 6 and you get x equals 15. All right. So let's go ahead and give you the opportunity to try a few on your own, and we'll check back in a second. All right, why don't you go ahead and check your answers here. Okay, x equals 15. And now in number 32, you weren't combining your x's, you were actually combining your consonants. So remember, again, as always, two separate sides of the equation, so you can only combine 15 and 10, not 43. Okay, let's go ahead and try our last one, which is something that is going to get you an introduction to geometry here a little bit. Okay, so we have to show step by step what we are doing. Okay, so what I'm going to do is just go ahead and rewrite my problem and the steps so that I can show everything that I am going to do here. Okay, so let's go ahead and start. Our first step here is to distribute. So you go ahead, 1/2 times 8x is 4x. 1/2 times -6 is -3. So we have 4x minus 3. So what do we do? Our first step, we distributed. 1/2 to 8x and -6. Next, what we're going to do, we have to start getting x by itself. So we're going to add 3 on both sides. By doing that, those cancel. You're left with 4x equals -20. So what do? We added 3 on both sides to start getting the variable by itself. Okay, lastly, divide by 4, and you are left with x equals -5. Okay, so don't forget to go ahead and describe that. What did you do? You divided by 4 on both sides to get the variable by itself. Okay, and that is notes. Okay, so what did we learn today? We learned how to solve equations, both one-step, two-step, and multi-step equations. So we learned a decent amount. Okay, so sooner or later we're going to take this into solving multi-step equations with variables on both sides. Okay, but now your homework for tonight would be worksheet 7. Okay, worksheet 7 is your homework for tonight. Remember, if you need to rewatch it, you can always rewind and pause when needed.